Hi, my name is Abdullah, and I'm happy to see all of you here. Today I'm going to talk about release validation in unstable world. What is our unstable world? We will figure out later in this presentation. So just a little bit information about me. I'm a software engineer in test. And I've been working with Sauce Labs since almost 3 years, and what I do is I always try to hardening the real device cloud. So I try to make everything stable, automate things, make sure we have everything easy and fast, and our customers are happy. And since we are talking about a little bit, we'll talk about integration test. I would like to introduce you my Slack name. So it has an integrated emoji inside. Yeah, that's it. So as Nina said, Sauce Labs, you can run if you develop an application, mobile application, you can run it on Sauce Labs, either on like a real device or a virtual device. But today we will be focusing on the real device cloud. Real device cloud in numbers, like there are real devices like this, and we have multiple data centers, so our devices are distributed in multiple locations, and we have more than 2,000 real devices. That means we have a lot of different shapes and models of these devices. We have more than 400 models, over 20 vendors, like Samsung, LG, whatever. Or iPhone, we have more than 30 OS versions, and that's a big challenge already. What is special in our environment is that real devices are required for validation. So, but they are actually, they have many issues. They may get stuck. We need to restart them. They may lose connection, like the cable has an issue, or a pop-up on the device might prevent us from doing test automation on it. Like they might have battery issues, they might run out of battery, or the battery might get bigger and explode, or it's not, yeah, but that didn't happen yet.
I have a picture on my phone of one bursting into flames. If anyone wants to see it, it happens.
Wow, I didn't know that. And we have customized distribution for them. That means that we need to treat them each one differently. And for update policy for iOS devices, for example, they always try to update their devices to the latest version of iOS. Like all iPhone devices should be on the latest version. But this caused an issue for us. This is a challenge somehow, because we need to block this. Customers still want to test their applications on older versions of iOS. And as I said, this is the challenge for us, and this is the thing which is special in our platform, that we need to test against real devices. It's just like testing against many third parties, each one doing something else, or you need to treat it differently. So we need to run our test against them in order to make sure that our release is deploy ready. But might someone say, okay, there is some traditional test methods. Why those methods don't work for us? Like, for example, a lot of people are doing like coding something, then building it, then running their tests, making a new release, deploying it, and that's it. This is like a CI scenario, maybe a common one, but this doesn't work for us because we need to test against real devices. So we don't have 100% success rates for our tests. And this is the biggest challenge we have. And we also cannot use mocks against devices. For example, if you need to test installing an application on a device, we need to really test that. We cannot use mock or mock the device, because if you want to mock something, you need to know exactly what's happening there. But we never know. Like if you want to really know if installation part, for example, is working, we need to install this application on a device to make sure this feature is working, as many other features. Yeah. So for this reason, we need to do an automated release validation. And that's it. Like it's important for us to have everything automated. Now I will tell you how we started when I joined the company, how it was, and then how it just started to get more advanced, and how we modified our release validation process to suit us, and to be more useful for us, or like efficient. When I started, it was just like some code on GitHub, and and we had like almost no automated tests, maybe 2 or 3 integration tests on Jenkins, and that's it. Like we were just running this test every time we want to deploy something, then do a lot of manual testing. Maybe that was taking like a full day of developer time, and after that, after spending so much time on this and doing so much things manually, we can deploy to production and make the product available for our customers. But manual testing, it's time consuming, not efficient. Developers might forget some parts of the application, don't test it, then we figure out later that we have a bug because of it. The solution, as you know, is automated testing, and try to increase our test coverage as much as we can. Then we did that. We added some different kind of tests which are needed for how our customers are using our product. They run some Avium test, XUI test, Selenium, whatever, some tests, and we run them against staging, and then we can deploy. But what are these tests actually? These are just like Avium is an open source framework for test automation. You can test your native application or mobile web application or even hybrid application which has like a web view inside. It's very powerful. And Espresso XUI and XUI tests are just test runners for Android and iOS. We have some end-to-end tests and API tests for our endpoints, and we have some Source Connect tests. They are just, what is Source Connect actually is like a proxy server. If you have your product or your website deployed locally or running locally, let's say, and you want to run your tests, your automated test on Source Labs against this locally accessible software, then you need to make a tunnel between them and use Source Connect to make the connection accessible between your test and your website or software. So this is what we have now. We need to, when we have something new, we need to make a release, then deploy it to staging manually, then run our tests, all of that manually when we need to, these tests are automated, but we need to trigger them manually, then check the test results one by one. After doing that, we can say, okay, the release is deploy worthy, we can easily publish it and deploy it to production. But this, I said manually many times, we need to take many manual actions. We need to trigger deployments manually, and also trigger our tests for validation each time. So the solution for them was auto-deployer. Auto-deployer is, we invented that, just a simple Jenkins job, which pulls for changes from GitHub. Whenever something is new, we make a release, we run some tests, and some unit tests and component tests, which are 100% successful, and after that we deploy it to staging. So we always have the latest release deployed to staging. We don't need to do that manually anymore. We always know that we have the latest one deployed. And staging test runner, just a simple one to keep triggering our tests over time whenever it's possible. And there's some benefits of that. We can get fast feedback from tests are running. So every day we have multiple releases, multiple pull requests on GitHub, and we need to make sure they are working, or we don't break something in a specific release, or let's say it in a better way. We want to know as fast as possible that something is broken on this specific release when it happened. And because this job is triggering all the tests one by one, always, whenever it's possible, we can easily know that we broke something. So this is what we have right now, but at some point we said, okay, we don't want each time to go to Jenkins to check test results. So we added Slack notifications to tell us about test failures and also about deployments. So when auto-deployer deploys something to staging, we know that. And our test results will be tagged with that release tag which we deployed. So they will be, we will figure out this specific release has this specific test failure. But we made a mistake. We posted everything in one Slack channel. And that was a big problem because we lost the context of our conversations. And yeah, so we were talking about something and we get many automated messages from Jenkins, and we ended up ignoring all the messages, and some of them were actually very important, and for this reason we just separated them in groups, or in channels. We put some channel for staging test failures, and maybe our main channel for production failures because they are more important, and many other. We just grouped them. We didn't post everything in one Slack anymore. So yeah, but it's still hard to investigate test failures. So we see the messages in Slack. We need to go click the link, click the link in Slack, go to Jenkins, see the logs, and they are a lot. We have many automated tests. What we did is we visualized our test results. And we implemented that using Grafana. So Grafana is a powerful tool, enables us to, I'll start from the beginning. Our tests will run over time, always, and they will report test failures to Slack and to a time series database, which we read from the time series database in Grafana and visualize the test results. After doing that, we were checking Slack and Grafana we were deploying to production. But what is Grafana also useful for is that we don't only visualize our test results, but we do also visualize statistics about our product in general. I will show you some examples here. This about our tests. So we have some test suites or some tests actually, and we can see the success rate for them, how many times they succeeded and failed over time in the last month in this case. Like we can see, for example, Appium remote install, installing some application remotely is passing 99%, maybe this 1% because the device went offline or they have no battery anymore or something. And we can see some other useful information like average testing time, and we have much more data there. Another example is this. And there is a funny story about this screenshot because I didn't take it. My manager did that and asked us in Slack. He said, "Okay, is that real?" you have 100%, 99, 99. Okay, that can't be true. Like, we used to have very bad success rates, not because our product is bad, but because our reporting system is bad, our tests were flaky. So, but we at the end, after a long time of enhancing our test process and release validation process, we reach a time that we have 100% success rate for some tests, really. And yeah, the funny part was that we were not used to such good results in our reporting system. This is another example from Grafana, and it's showing device availability. What is device availability is, like you can say, I can use my phone always, it's always available, but this is actually not the same at Sauce Labs. We are using devices in a different way. We are using them not in the same way that they are designed for. So we keep them connected all the time. We keep cleaning files from them. We keep doing a lot of stuff on them. And available at the end means that they are available for running automated tests on them. So you can see, for example, iPhone X on staging is 98% available, and that's good. But we can see that maybe this instance of Galaxy S6 on staging has a 69%, so not that great. So we need to make sure that this device is available 100% or not 100%, available more in the future, or we need to investigate some failures there or see what is wrong with this device. So with this visualization, it enables us to just from one look at the graphs, have an overview about all of our staging and production devices. This one is for also device availability, but over time. For example, we can see a device here, like between 5 a.m. maybe and 6 a.m. almost. It went offline. This means it went offline, maybe because it doesn't have any battery anymore. And a lot of colors are maybe devices going offline for maybe 5 minutes, 10 minutes, like for a short amount of time, and they maybe recover or like auto-recover after our release validation process. So they go offline and go online again from automatically. And when we see that, we say, okay, our platform is good. And this color here is like this yellow color is one device which always unavailable. And we can see that as well. Maybe it's doesn't have any battery anymore, or maybe it's not in the data center anymore, or we need to the important part that we know about it and we can handle it. And then our release validation process. This is the final shape. When we have something new on GitHub, we try to make a new release, and our auto-deployer will deploy our new release to staging. Our functional tests will run during the night for 2 hours. Like at this time we said, okay, 2 hours functional test running is good. They will run for 2 hours. And then after that, our stress tests will run continuously against our devices. So what are our stress tests? We just try to run some Albion tests against our devices, make sure they are accessible all the time. We can put some stress on them. We can see how they recover, how they handle many requests at the same time. So currently we have more than 8,000 daily stress tests against our staging devices. And after we run the functional test and stress test overnight, it's almost like early morning. We can wake up every day in the morning, check results on Slack, check results like Grafana dashboards and graphs, and say, okay, that looks good, no exceptions, nothing abnormal, everything looks good, then we say we can deploy. We push the button and we deploy. And this is our release validation process today. And some example about Slack messages, because I didn't show you. When our load test starts, or stress test, I call them here load test. When our load test starts, or stress test, we can see, okay, 11 devices were available out of 11 in the US data center. And at the end of our stress test, we can see the exact same number, but we can see after running our stress test, 3 devices went offline. So you can see, okay, 3 devices went offline, maybe they don't have battery anymore, or they have an issue or something else. So we keep tracking these numbers. It's easy for us to see them. And this is the final results. We can see functional test success rate, for example, is 98%. It's never 100. And we can see that our stress tests are 94%. This 94% doesn't necessarily means that our stress tests are bad. But this means that we are running our test in a way that always gives us between like 92 and 96% at maximum. 94 is good, like if you have the range between 92 and 96. So we can see this, then check if we have exceptions, check everything, then as I said, click the button and deploy to production. So the summary. We can deploy daily, on a daily basis. Every morning we can wake up, check our release, check everything. Like this will take ideally 10 minutes, but sometimes it takes a little bit more, like until maybe 30 minutes, because we need to investigate some bugs or something we didn't know about, or we are aware that we broke something, like ensuring quality for enterprise customers is not like, it's not an easy thing. We can deploy daily. We would like to be able to deploy every minute, but unfortunately this is not possible until now. And we get fast feedback about our test, our staging runner, which I talked about, just run the test all the time and give us fast feedback about our test failures. The process is automated, and we have statistics. From one look at the statistics and Grafana dashboards, we can see everything is nice and cool. And our developers are happy. This is the most important part. They don't need to spend half a day or maybe a day on just trying to verify a release if it's deploy ready or not. Because in the past, at some points we needed to maybe delay releases just because we had bugs, and we knew about that in the last minute. And with this setup, we don't have this scenario anymore. And yeah, so I told you about all of our release validation process, and we really have learned some lessons. Building a release validation process may take time. We didn't implement that in 1 week or even 1 month. That took time, took more than 1 year and a half from us to reach this shape of our release validation process. And it's a continuous effort. So, like this unstable world, everything changes, your product is changing, and everything is changing, so you need to keep it up to date always. And also, one important thing, we always try to start simple, then get more advanced. We sit like this guy and think, what we need now? We say, okay, we have, like, for example, we need some messages. We added Slack messages. We need some, it's hard to investigate test failures. We added Grafana dashboards. we just tried to do everything step by step, and we didn't think about the full, perfect shape, but we think about everything step by step. We thought about everything step by step. Yeah, and you know, this release validation process is not perfect, but it absolutely works for us. That's it. Thanks. Any questions?
So, thank you. The question is how you select the set of the devices that you run tests against. I will explain. I've been using South Labs before test objects, and what I noticed from my experience, some devices are more stable than the others. So for example, for some devices, there is some weird stuff like while starting the test, there is a system pop-up that overlaps the application of the test, and basically your pipeline will be dead. No way to run the test. So like, why I face it? Because each pipeline, I select randomly device in the group of devices of the potential users I use in a particular country. Are you dynamically selecting your devices to run tests against, or they are like hard-coded and always the same?
This is actually a very, very good question. At the beginning, we faced the same issue. Like, we tried to use our product in the same way as our customers, and we said, okay, devices make it offline for many reasons we mentioned today. So, but we still want to keep our test passing at least. Maybe we don't care about specific device, but we care about platform version or screen size or something. We have introduced some dynamic device allocation, if you heard about it. It's something that you don't specify the device descriptor ID. Instead of that, you just say, I need like an Android 8 device. And you get Android 8 or 8.0, 0.1, or you can see, it's like, you can select a platform version like this. Or you can even select the device name by, it's a regular expression. You can put like a device, comma, or not comma, maybe it is separator, and another device. This also works. Like this is all regex.
I'm doing it. So I'm using SalesLabs API.
But you get pop-ups.
Yeah, I'm getting devices with the pop-ups.
Yeah.
So they are displayed like available. So I compare my list with the available list. Choose like what's the common ones. Select random from this already like mapped stuff, and get this device.
Got it. Yeah, this is also another thing. Sometimes you get pop-ups, and they are very annoying. And we try to, the thing which we do now is we try to dismiss these pop-ups automatically. If we couldn't, we try to do it in our tests. Like in our platform, we already try to dismiss all pop-ups which appears. But sometimes there are special pop-ups which we cannot, or they are new, or we have like a lot of devices. We cannot do that for all devices. Or we try actually, but we cannot. So we try in our test to put a try catch or something, and just try to dismiss this pop-up if we see it.
So just to clarify the question, are you randomly, every time everyone you select random devices, or it's like always Samsung, next was 5X?
No, I actually, in our test, I only set like a test object API key, and the URL, like endpoint, and the third thing I might use is the platform name, and that's it. I just keep our tests run on all devices. Yeah.
I have a question. You mentioned thanks. I have a question. You mentioned storing the results from Jenkins in the time series database for visualizing with Grafana. Can you go into a bit more detail on what exactly you store there? Is it just the exit status of the Jenkins pipeline and how the integration is done, the storing?
Yeah. So on each test run, we don't only store the exit code. We store, like you have seen some dashboards, like this. We are apparently like storing the device name and the success, like the result, 0 or 1. And for example, here we are storing the testing time. You can basically store everything. And sometimes we do that from Jenkins, in a Groovy code or something. And sometimes we do that from the Java side. It doesn't matter where you do it, but it matters what you store. Like at the end, you need to store your data or structure it in a good way that you can do group by maybe, or like visualize it in a specific way. And we have made some mistakes there at the beginning, then we fixed everything. Any question?
Thank you. I want to ask you about the results. What is acceptance rate for you to make a release? Because you have leaky tests and probably you have failures up to time because environments may be not the same or device is not available. So what percentage of these failures you accept for release?
Ideally, we would like to have 100%, but that's not possible. But what we do, like for this, for example, when you see it in orange here, for example, that means it's maybe acceptable, but it's not that good. We need to pay more attention. But at the end, what we care about is the product itself, not the test. We make sure that we don't have any exception or a new thing or abnormal behavior happens on our platform, more than just checking the numbers. The numbers are important, but not important like not breaking the feature we have, the product we have. So the numbers can apparently reflect the status, but we still investigate every single exception. So there is no specific number.
Thank you. One more question specific. So you mentioned about status reset of the devices. So what I also noticed, some of the devices have enabled airplane mode with enabled Wi-Fi. Some devices have only Wi-Fi. What's your criteria on setting a proper default state of the device? What is it how it works from time to time, or it's
Yeah.
Maybe you can tell us how you set it.
I think we always make sure that our devices have internet connectivity. And we also try to enable all the features there. Don't block anything to give the user the full experience. But why some devices have airplane mode, why some not? I'm not quite sure. It's more like a dev question for our data center team. But what I know that some devices have carrier connectivity, so you can use real SIM cards in the devices, and those devices doesn't have any doesn't have the airplane mode.
I'll add something a little bit maybe obvious, but I work in sales, so it's that's how you should expect it, I guess. But so what we try to do really with these new devices is always bring them back to this ideal sort of zero state, right? The problem is that we always have to sort of battle with what the actual device allows us to do. So sometimes the underlying operating system does not make it easy for you to automatically go back to this state for a subset of functionality. And unless something has changed since I was developing Android applications, which was quite some time ago, there was not an easy way to reset it. Maybe now it has changed, but yeah. And also for iOS, that's, as you can imagine, that's even harder. So we try our best. We were not always able to just find a hook there in the operating system of the underlying phone or tablet to bring it back.
Thanks, Abdulla. Actually, I have two questions about, first one is about deployment. What are the entry level for deployment? I mean, what could you prepare for your deployment in order to avoid any kind of unsuccessful deployment? And the second one, you have mentioned just about mobile app testing. Is the same framework also for desktops or not?
For this one?
Desktop.
Desktop. Yeah. The first question, how we avoid any things which are not normal in when we deploy. What we do is we try hard to investigate every single failure we have. After that, like when we see something in Slack or Grafana or something, we try to investigate it hard before we deploy. Then when we are sure that everything is working, we try to deploy, and we keep watching that deploy airdrop. When it finishes, we trigger our tests against production, make sure they are still working. If not, we just roll back and deploy the latest one.
What are the most common problems or issues that you have faced based on your experience before deploying, after deploying?
The most common problems which we faced after deployment, something like a test is failing, or a feature is not working anymore. Then we know that we need to roll back. Or even sometimes we deploy like a hotfix. Sometimes we know that it's just a small thing. We just immediately deploy a hotfix. But in most of the cases, we just roll back and deploy the one before. The second question about Appium. Appium is based on Selenium as far as I know, and it's only for mobile testing, right? No?
I can answer.
This guy is expert.
So Appium implements a mobile JSON protocol, which is like a friend from the JSON protocol, which is now called WebDriver, and Selenium, to clear that up, is basically just a framework that can speak that protocol. The good thing about Appium is that they are targeted to support any devices, and the goal is actually to do that for IoT. So you can actually, besides mobile phones, you can also automate Mac applications, Windows applications, Windows 10, they have a good driver for that. They just released it last Selenium conference. And I, by the way, also built a driver to automate application on smart TVs. So as long as they're a driver for Appium, you can automate it any kind of device.
Any other questions, please?
Should I start?
Yeah.
Hey, you mentioned that one of the biggest problems is basically the vast amount of logs you get from your Jenkins processes and stuff like that. And you get more or less rid of it, or get an overview using the Grafana. Did you try to use something like the Elk stack or something like that to manage those logs better? So using something like Logstash and Elasticsearch to, if you see in Grafana that there is an error, you get faster to the source of the error in the logs. Because you're applying DevOps or dev or operation tools to such a problem, and it's near to go to the next level and use the same stuff to manage your logs or stuff like that.
Yeah, as I said, our current process is not ideal. We always try to make it better. Until now, we don't use, we only use log entries. for storing logs. We can easily check for, not so easily, but some kind of easily check for exceptions and logs. But we don't use yet any smart solution for our logs.
Yeah, so there's something more about that. Yeah, log entries is kind of like an alt stack, but the thing that we have is, well, we are talking about logs from the test. So what we have finally is inside the test or outside a test watcher that just gets a result and puts it to InfluxDB, because then it is related to the test. So you could do it to the log system too, but yeah, then you kind of lose the top context. If you already have the context, why not just putting it automatically into the InfluxDB so that everything is together?
Yeah, no, stay. Good question. The first, I'm not sure that this is applicable, but did you take in consideration to make an A/B or canary testing for node deployment to have a complete switch? And the second question is, you mentioned about flaky test. That's probably the 98 and 97. That did you try to handle the flaky test somehow with some retry mechanism, or no, identify what is more flaky than other and try to invest on that? Or you take that 92, 97 is fine, and then you don't care much?
About the flaky test, we created a channel for that. We made a meeting. We said, okay, we have some flaky tests. We need to make them better. And we have chosen the most annoying one and fixed it. Then 1 week later, we picked another one and we tried to fix it and put some effort and time, spend some time on it.
How can you detect that it's flaky? Which way?
Because you don't see the results which you expect. So when I run a test, I expect to either to show that my feature is working or my feature is not working. But when I see something else happen in the way to that result, or something I didn't expect, then I know, for example, we have some end-to-end test. That was very flaky. That was about testing the manual testing or live testing experience. So we need to make sure that our live testing is working. We automated that in end-to-end test. We had a device. We tried to click and check if the click is in the right place and our manual or live testing experience is working. But during this test, there were in many times something happens or a pop-up comes out or something unusual happens. When we see that, we know that this test is flaky. Sometimes we see our test failing just because it couldn't do what we expect, just like a timeout issue or something else. And yeah, it's hard to talk really about a flaky test, but they are all different. And the second question was
The deployment, if you know how to evaluate that A/B test, what A/B or canary, not canary really. You start with small quantity, to update on your small quantity, verify that everything is fine, and then roll out and test.
I think we have unit test, component test, end-to-end test, API test, end-to-end test. And our end-to-end tests are already testing some more areas than they should do. And this way we can we have some kind of a smoke test or something, specific scenarios. But other than that, no. I think.
No other question, we have a small break.
Yeah, we have a break. Thank you very much.